Hi class, in this recording we're going to be focusing on PhysioEx exercise number 6, activity number 5. Actually, I'm going to double check that activity number. Number 5. The effect of ions on heart rate. So as we look at this activity, we're going to be focusing on two new vocabulary words, endotropic first and chronotropic. When we look at endotropic agents are going to affect the force of contraction, and then chronotropic agents are going to affect the rate of contractions, or the heart rate. In our heart, we have pacemaker cells. These pacemaker cells are special cardiomyocytes that are going to depolarize at a very rapid rate. So, if you have not yet watched the recording on the cardiac action potential graph, the CAP graph, please make sure that you watch that recording. It's assumed that you understand the CAP graph. The CAP graph was discussed in detail and explained in detail at the very beginning of this with the introductory material before activity number 1. So, enough of that. Let's go back and focus on activity number 5 here. So, for activity number 5, you are working some chemical modifiers. Here are the phases of the cardiac action potential that correspond to our CAP graph. And during the activity, you had this experimental setup. So you had a frog heart that was beating, and you had different ions that you could drip on the frog heart and then record the changes in the heart rate. And when you were all done recording those changes in the heart rate, you ended up with this data table right here. And what we found from our baseline of 61 beats per minute, calcium elevated the heart rate, sodium lowered the heart rate, and potassium really lowered the heart rate. So we found that calcium, as we're looking at these graphs associated with that, calcium ions increased the heart rate, and sodium ions decreased it, and then the addition of potassium ions decreased it significantly. Let's go back to our questions. Define chronotropic and endotropic effects on the heart. Chronotropic effects are effects that alter the time in between beats. As we look at this root word, chrono is a root word for time. So if we change the heart rate, that is going to be a chronotropic effect. And when we think of an endotropic effect, that is going to be an effect that changes the force of contraction. As we look at question number 2, describe the effect of adding calcium ions to the frog heart. Officially, and I've already had this jotted down, it's going to affect the pacemaker cells of the sinoatrial node. It's going to cause an increased heart rate. And because the action potentials are moving closer to threshold, and it also is going to cause an increased force of contraction. As we look at our data, the addition of calcium ions very clearly, objectively elevated our heart rate from 61 beats a minute to 71 beats a minute. More difficult to determine from this graph is that the addition of calcium ions officially is supposed to increase the force of contraction. So we should see a slightly higher peak on our ECG graph. However, as I'm looking at this graph, I can't zoom in and I can't discern that slightly higher peak right here relative to our baseline. For the purposes of this lab, though, we're going to say that it increased the force of contraction. We're going to be skipping question number 3 because question number 3 gets to be kind of a quagmire, and I'm trying to really streamline these concepts for you. And as we look at question number 4 asks what the effect of adding potassium ions, the initial effect of adding potassium ions, was to the frog heart. Let's just go right back to the simulation and Okay, so as we look at the effects of potassium ions on the heart, let's just go, the initial effects, let's just go right back to that simulation. Oh, wrong button, boop, boop, there we go, here's the simulation. I have some potassium ions. Our baseline heart rate is 60 beats a minute. Then I'll add some potassium ions. And instead of being 60 beats a minute, it goes 58, 57, 56, 60, 57, 56. Initially, there's not that big of an effect, but over the course of several seconds, it decreases the heart rate significantly, and the peaks are noticeably shallower, which means that we have reduced force of contractions. So the initial effect of adding potassium ions to the frog heart was not very pronounced, but over time we have decreased heart rate and decreased force of contractions. So it is a negative chronotropic and negative inotropic effect. That's all we have for this recording. If you have any questions or comments, please feel free to post them in the class discussion board. And as always, happy studies.